Okay, amines are organic derivative of ammonia. Ammonia is NH3, wherein one or more alkyl, cycloalkyl, or aryl groups are attached to these nitrogen atoms. So the function of all amines is amino group, or that is the NH2. Secondary and tertiary amines are substituted amino groups or possesses substituted amino groups. Now we have three classifications of amine: primary, secondary, and tertiary. For that primary amine, the amine group, this is an amine in which the nitrogen group is bonded only to one hydrocarbon, and at least it should have two hydrogen atoms. So always focus natin is the nitrogen. For that to be primary amine, there is one hydrocarbon, or this is a series of carbon atoms attached to it, and at least it has two hydrogens. Always bear in mind that the bond requirement for nitrogen is 3. Unlike for carbon atom that is 4 and hydrogen that is 1, for nitrogen it has only 3. Okay, so for example, this is the nitrogen. So it is attached to a series of carbon atom, only one series of carbon atom, and the remaining bond is allotted to hydrogen. So this is a primary amine. Also, this is the primary amine. This is the reference nitrogen. So it is only bonded to one series of carbon atom, and the rest of the bond is for hydrogen. For it to be classified as secondary amine, still the nitrogen should be bonded, but this time to two hydrocarbon or series of carbon atoms, and the other one is allotted to a hydrogen. So as a general structure, this is the N. It is attached to a series of carbon atom and two series of carbon atoms and a hydrogen. Take note that the series of carbon atoms here may be same or not. So ulitin natin, the R and the R1 may be the same or not. For an example, so this is an amine. It has the amino group. That nitrogen possesses a series of carbon atom. For this side is only one carbon atom, and the other side has two carbon atoms. And the remaining bond is of course allotted to hydrogen. With that two hydrocarbons being bonded to this nitrogen, therefore it should be classified as secondary amine. Still, this is the nitrogen. It has one hydrogen on it, and this is an alkyl and this is an aryl, which is attached to the nitrogen. So there are two series of carbon atoms being attached to the nitrogen, so therefore it is a secondary amine. On the other hand, tertiary amines, these are type of amine into which the nitrogen is bonded to three hydrocarbons, and that no hydrogen is no longer attached. So there's no hydrogen attached with the reference nitrogen, so it is attached to three series of carbon atom. Again, this series of carbon atom could be or could not be the same. So this is the nitrogen, which is the functional group for amines. The hydrogens has been replaced by series of or by an alkyl group. In this case, the alkyl groups being attached to nitrogen are the same. So they all bear CH3s. Okay. For another example, the nitrogen is bearing an aryl group or a benzene ring. So and another alkyl group. So no more hydrogen could be found to be attached in the nitrogen for a tertiary amine because the nitrogen is bearing three series of carbon atom. Okay, so those are the classifications of amine. For the nomenclature, we could have a common system of nomenclature wherein you are just going to list the alkyl groups being attached on the nitrogen in alphabetical order plus adding the suffix amine. So this if alkyl groups um, appears are identical, you may use di or try to denote that they are the same. So for example, this is the nitrogen or the amino group which is the functional group for amines, and the series of carbon atom attached on it is an ethyl, so therefore this is an ethylamine. Okay, and then this is another type of an amine. However, this time there are two identical alkyl groups being attached on it, so therefore we are going to use the prefix di and the name of the identity of the alkyl, which is methyl, so that is dimethyl plus the word amine. And another example, this is a tertiary amine. It has a benzene ring, a series of carbon atom with two carbon atoms, and a CH3. So the identity of this substituent being attached on the nitrogen are different. So we have to consider their names in alphabetical listing. So benzene ring as a substituent is named as phenyl, so that starts with P, and this is two carbon atoms, so that's ethyl, and this CH3 is methyl. So alphabetical listing, ethyl first, and then followed by methyl, and then the name for the benzene ring, which is phenyl. Take note, we are not going to make use of the word benzene if the ring or this ring is used as a substituent. We are only using benzene if it is a parent chain. But since here it is treated as a substituent which is being attached on the nitrogen, so therefore its name is phenyl. Overall, the name of this amine is ethyl methyl phenylamine. Okay, so for the IUPAC system, you have to choose, rule number 1, you have to choose the longest chain of carbon atom that bears the nitrogen to be your parent chain. So always bear in mind, look for the nitrogen, to what carbon it is attached, and that carbon atom should be included in the parent chain. And then look for the longest chain. Now, name the parent chain by removing the E ending from its alkane name and add the amine. So if the longest chain, say for example, has 5 carbon atoms, so that is pentane, because these 5 carbon atoms are attached in a single bond. However, with the presence of the amino group makes it an amine, so we are dropping the E and then adding the suffix amine. Okay, so therefore the parent chain would be pentanamine. Okay, so dropping the E and then adding the suffix amine. Now you have to number the parent chain nearest to the nitrogen atom because that's a functional group, and being as a functional group, that would be the priority. And then rule number 4, you have to attach the position of that nitrogen in front of the name of the parent chain. So say for example, so this one, it has 4 carbon atoms. This is the carbon atom that bears the amino group, so it should be included in the parent chain. And you have to number it from left to right, so that the carbon atom that bears the nitrogen will become carbon number 2 and not number 3. Okay, and with that, with rule number 4, you have to indicate the position of the carbon atom to where the amino group has been attached. So therefore, that is 2-butanamine. Originally, it has 4 carbon atoms, so that is butane, but we are dropping the E and adding the AM, the amine suffix, so that is butanamine. And the position of that amino group is at carbon number 2. So therefore, this one would be 2-butanamine. Okay, and another one is this example. So we have, this is the amino group, this is attached on this carbon atom, so therefore this carbon atom should be included in the parent chain. We could have this to be this as the parent chain. It has 4 carbon atoms, so that is butane, but we are dropping the E and adding the amine suffix, so that is butanamine. Eventually, this amino group is attached on the first carbon atom, so we are putting 1-butanamine to locate NH2 in that butanamine. And numbering it, this one would be carbon number 3. What is not included in the 1-butanamine is this substituent. and the identity of that is methyl, and eventually it is attached on carbon number 3 of the parent chain. So therefore, the name of this is 3-methyl 1-butanamine. Always use the dashes to separate word from a number. If, for example, there are two amino group, then therefore we are going to name this as diamine. Remember, a while ago, if there's only one amino group, we are dropping the E and adding the suffix amine. But this time, if there are two or more amines, you have to retain the final E from the name of the alkane's name. So that would be retained for the E's pronunciation and adding the prefix or suffix rather diamine. So for example, this is the carbon atom that bears the nitrogen. It should be included in the parent chain. So therefore, this is the carbon atom that, or this is the longest chain of carbon atom. It has 4 carbon atoms, so that is butane because of the single bond. We are not anymore going to drop the E. Rather, we have to retain that butane and then add the suffix diamine. The diamine indicates that there are 2 amino group present in that chain. Now, again, we have to indicate the position of this amino group, so therefore we need a locant, and that would be numbered from left to right or right to left. Either way, we are going to come up with the same set. This is carbon number 1 and this is carbon number 4. And that would be reflected on the name, so therefore the name is 1,4-butane diamine. Remember, a comma would be used to separate two numbers and a dash would be used to separate word from a number. Okay, now what about if there are, how to name the secondary and tertiary amines? These are known as the N-substituted primary amines. So we have to make use of the locant N to denote any substituent being attached on the nitrogen. So paano ito? So this one, so the parent chain will be, for this example, so the parent chain is composed of 4 carbon atoms. Eventually, the functional group is attached on the second. So that is carbon number 2. The name of this parent chain is 2-butanamine. Butanamine, but indicating that there are 4 carbon atoms. Butane supposed to be, but we are dropping the E and suffixing or adding the suffix amine to denote that there is a functional group of NH2. What is not included to the 2-butanamine is the substituent CH3. But this time, the CH3 is no longer attached to the parent chain. Rather, it is attached on the nitrogen. So, we have to make use of a locant N to denote that the methyl group is attached on the nitrogen. So, therefore, the name is N-methyl 2-butanamine. The N indicates to where the methyl has been attached, and that is the nitrogen. The 2 indicates the position of the amino group in the parent chain, and that is this one. Okay,